Hello everyone, my name is Arseny and I've decided to share some of my experience with this beautiful Rhino Inside plugin which was created by McNeil and Associates. This is WIP version, so it's a work in progress, and but this is a really powerful tool even now, and if Autodesk not messed up with this plugin, I hope it will be really a game changer. Well, I have more than 8 years Grasshopper experience. I'm former architect, and I have Revit experience as well, and from the day I learned Grasshopper, I was dreaming about something like some way of flawless geometry and data exchange between Revit and Grasshopper. And there was some tools for this, but none of them was doing it the way I want, and I was not the only one. It's obvious, but well, let's just start it. So, what is the Rhino Inside? Well, first of all, is the plugin for Rhino and Revit, which allows you to load Rhino and Grasshopper inside the Revit. This is where the name came from, I guess. And you just go to add-ins and click Rhino icon, and you then go to this menu. So here you can separately launch Grasshopper and Rhino. And what I will do now, I will show you some features, how to transfer some geometry from Rhino to Revit via proper Revit families. So I have a small script. I will launch it in a second. First of all, we need to launch my Rhino file, and then we can start up Grasshopper. You can start it from Rhino, as you do, and you can start it from Revit right here. So I have this already created script, which I created for my series of lessons for my co-workers. This is Grasshopper lessons. So what we have essentially, this is a small script. What it do? It's create some geometry of the building, or if you can name it so. This is nothing fancy. This is just slabs, columns, and exterior walls. No windows, no doors, no architecture in this. So this is just really easy, simple model. Well, it has some features. It has some pros and cons, and but it's enough information to show you some functions of Rhino Inside. So this script depends from geometry in Rhino. I have these two like plane floor plane layouts, which I can change. I can change elevations, I can change number of floors for each section, big one, upper one and lower one. And this is, well, I can change the column sizes, thickness of the floors, and well, this is generally it. Well, what I want to do, I want to export this geometry into Revit. Not just geometry, I want to do this via Revit proper families. So let me hide all the stuff I don't want to see in Revit and show some things I want to see in Revit. So first of all, you can see that geometry is already visible in Revit, but it's just Grasshopper geometry. So you can select it, you can change it, you can do pretty much anything with it. But it's here, and let's just see what we can do with this. Well, first of all, let's create columns. Let me find them. Here we have columns, that's walls. Here we have columns geometry in Grasshopper, and what I want to do. So I want to open the Rhino Inside toolbar. This is the separate tool set for this plugin, and it works only when you start Grasshopper inside the Revit. There's no way to see these tools from just Rhino and Grasshopper. Let's do just super easy things. For the start, I will add column by curve component, and what I do, it's creates column from line, vertical line, which represents its height and position. So let's do this. Let's hide this extrusion. We don't need this. And let's look at what we can use for this column. Well, I don't have line because I do this column by extruding the plane surface. And to create line, I can use this point I was using to create the surface as a start point. So I go to curve, take this line SDL, start direction length, start to point, direction to, well, just Z. I can use this Z unit, but it not create my line, and length to this one. I use these two nodes to create this extrusion, so nothing new. So now I have lines which same length as my columns. And now let's plug in the columns. So this is the curve. I plug it in, and I see in Grasshopper this geometry. And let's look what we have in Revit. In Revit we have set of columns. Well, the main problem with this, this is not the right columns, not the columns I want. So how can I change the columns? Let's go to Grasshopper again, and let's see what else we can change in this node. So we have type, this is the one we need, and we have level. Well, level we can change it, but let's not mess with it this time. And so what I want to do, I want to change the column types. Well, I have some issues now, I guess, because my Revit is in imperials and my Rhino and the script is in millimeters. I'm not sure, but it's I guess it's changed. It somehow automatically converts this. So I just noticed this. Let's see. Yeah, I guess so. Well, I have these columns like 15 feet with something, and in Grasshopper, let's see what is the floor height. The floor height I've set for this first 3 floors, I've set it to 5 meters. So it's look like it's working properly. Well, let's change the columns, shall we? First of all, let's see which column type we have here in Rhino. I've already loaded some concrete columns, one of them with 3 types, and this is concrete rectangular column, and I will set it here. I want to set it here, so open my Grasshopper again, go to node, and well, here we have some options. Well, the easiest way to do this is to take this element type by name node. I was confused when I tried to use it for the first time, because you see, because why? I cannot do this. I cannot do anything with this, and this is because you should plug it something to it. It's not look like you can, because there's no this small knob on this side, but I will show you that you can. So you have an options. You can take a family speaker, but it uses filters and it's kind of messy. And you can take for walls. You generally you can use model categories speaker. So you add this into canvas, and let's see what it has. So it has all the Revit model categories, and let's find structural columns here. Here it is. We pick it, and now you can plug it in to this small node. As you see, it's automatically changed its shape, and now it have all the options we have in this structural columns type. Well, not type, family. Oh, category. Yes. And now when we have type, so you see this is an element type. You can choose one and plug it to the type. into this node. Well, we'll wait, and bam. Now it's the concrete rectangular columns. You can change type anytime. So go here, change it to bigger ones, wait for some time, and here we have. Well, let's do floors, I guess. So it's generally the same. So go to build, add floor by outline, and for outline I will use my outline, because I have here I have my floors. You can see this, and it was created by extrusion of flat surface, which I was created from these contours. So I will use these contours or closed curves or rectangles. So I will use them as my outline or boundaries. So plug in boundaries here, and here we see that we have our floors. Well, with floor you can do the same. You can change its type, so you can just copy this too. Change model category to floors. It's not very convenient to use this, but let's see, floors. Here we got some options. Let's take some 14 inches floor and plug it to type. Here we have its changes, and because this is the proper Revit family, I mean about columns and floors, you can see that, oh no, you can't see this, because I was sure it will cut it or connect the column to these floors, but it don't. Well, let's see what we can do with this. First of all, let's just reset this columns. I just reconnect the type node, and let's see maybe if it creates its again. Maybe no, it's not working. So this is the good opportunity to show you how you can change some parameters of already created objects inside Revit. So here we with columns you have some parameters here, and I need constraints or construction for this, and I need top extension. So the thing I want to do, I want to use top extension, use some negative number to cut this column, and let's go to Grasshopper again, and let's see what we can do. So this is like something like backwards logic with this. You can change some parameters of already created objects, but not before you create it, just after you create them. Let me show you what I'm talking about. So let me see what we can use here. Built-in parameter by name. Let's use it. This node, you can plug it to already created geometry, and you should. Oh no, it's not the one I want. This one, element decompose, I guess. Plug it to this floor and get common parameters. So here we have all the common parameters of this. Oh, I don't want the floors. I want columns. Yeah. And get common parameters again, and here the common parameters of the columns. Let's see what we need. We need construction top extension, and now we can use set element parameter. I want to, oh yeah, element parameter set. So let's plug the element. This is our columns. Let's plug the parameter key. This is our parameter name from this node, and this is the top extension, and we need some values. So let's do well, I will use millimeters, but it can go wrong. I'm not sure that this parameter will automatically convert my millimeters into inches, but it's fine, or we'll change it if we need to. So let's plug and negative. We should go negative here and plug it to volume. Yay. Well, as far as I see, it still converts. So now we need to figure it out how thick our floor was. So it's 1440 inches, and just use some math nodes in Grasshopper to make this value dependable from the thickness of floor. So we can get so here we was setting some values, but we can also get some values. So it's generally almost the same. Let's remove unconnected parameters. So it's now small, and let's plug this node again, but now to our floors. Get common parameters, and let's see thickness. Here we have, and now we go to element parameter and take this element parameter get node. So that was set. This is get. Plug it here. This is our elements, and here our thickness, and here we have our thickness of our slabs. Now it's in millimeters, and I guess we can, well, I have this line in Grasshopper. Let me you see this. In Grasshopper, I have this line length depended from my Grasshopper floor thickness. So we can, oh, I'm sorry, I clicked wrong way. Here I can plug to where is my thickness? Here it is. So we have 300 millimeters, and generally we can use minus operation to have our difference. So we subtract and what we have 300. Why we have 300? Oh, this is because this values is not the integers or floats or anything. We should convert them via this node. Now this is floats, and now it should work. Yeah, and now result we can plug it here. Okay, we have our columns just right. And the last one is our walls. So let's create walls. I have my walls here, and we see we have kind of same problem. We have walls are too tall and too wide because we have changed the columns. Columns are going from Revit. Well, essentially it's the same. I will not show you how to make it more thin or shorter because it's like same operations, but I will show you how to create walls. Let's remove unconnected parameters, okay, and go to Revit and go to build. Let's take add wall by curve. Here we have, and again we will use curve. Well, I have my curve I want to use, so this is it. Let me show you it's in Rhino. Here they are. So what I doing in this script while I show my coworkers how to build it, I've created some contour. I've subtract the columns from it, and I have this like lines which represents the outer walls, and then I offset them in both ways and create surface in between them and extrude it. So not the best way to do this, but it's working. And so we can use these lines to create our walls. So just plug this curve here, and we already have some walls, and in Revit we have them too, but they have wrong height. So to change height of the walls, let's not we will not do this parameter set. We just subtract our difference which we have already from our height, which I was used to extrude walls and columns. So here we have this numbers, and we plug it here and subtract from it. Well, let's check our data, because I have different data tree. So we have some options, but I guess the best way will be just took one of these numbers because they are all the same. Took one of this and subtract it. And here we have our wall height. Let's plug it to, let's check our data matching. Here we are. It's all right. And let's plug it. Why I'm not using single number for these walls is because in my script I have different story height. So for this part and for this part there's different height, and walls are changed differently. So let's see what we have here. Okay, that's great. So what we have, what we can do to make this walls and just before the column, not inserted. There's several ways, but the best way is to cut our line. Well, let's use some mixed techniques. So here we changed some parameters or get it from existing geometry, and here we will use some of this geometry, like this column here, column geometry. Well, we will use this one because it's already changed height. Not like that this is matters, but we will use it. And we will take this element geometry, which gives you proper Rhino geometry from Grasshopper, from Revit families. So this is just closed VREPs now, these columns, and let's match our data. I will use string tree. Here we have, and let's plug it instead of this let's see here. So I was cutting a curve by these surfaces, and now instead of these surfaces I want to use the footing of column of our new column. So we have this geometry, and we can get this from it. So let's explode it and find the proper surface. This is the top one, I guess. No, it's the bottom one. This is the one we need. Simplify this, and now we can use this right here as a region. Let's plug it, and let's see what we have. No, it's not working. Why? Let's see why it's not working. It should, but it's not. Well, maybe our data are not matching here. Yeah, that's right. So we need to trim tree once again, right here, and now it should work. Yeah, and yes. Let's go to Revit, and here we have our walls. Well, that's it, I guess, for this first lesson. I hope it's not the last one. And let's just see how this script working when I'm changing some parameters. It's always interesting. So let's change the height of first 3 floors. Yeah, it's working. Slowly, but working. Okay. And let's change the number of stores of this tower here. Here we have 5 of them. Well, it's 6 here, but this is some mutual problems of this script. And let's see how fast it will create this additional floors. Well, it's not flawless because it's a lot of geometry, and my script and Grasshopper are not optimized well, but it's ready. Whoa, it was too much, I guess. Well, and that's it for this lesson. I hope you enjoyed it and hope you learned something, and thank you for your attention. Bye.